In 1922, a vital water pipeline beneath New York Harbor suddenly ruptured. Buried under 50 feet of water and more than 20 feet of mud, it posed a challenge few engineers had ever faced. What followed became one of the most difficult underwater repairs of its time. Just a few years earlier, between 1914 and 1915, an ambitious project had taken shape beneath the Narrows. A 36-inch cast iron pipeline, nearly 10,000 feet long, was laid across the harbor to carry fresh water from Brooklyn to Staten Island. Built from 12-foot sections connected by flexible ball and socket joints, the pipeline was assembled from a floating derrick scow and carefully lowered into a dredge trench on the seabed. Once in place, it became a critical lifeline. Then, in February 1922, disaster struck. A dredging operation accidentally ruptured the pipeline, forcing an immediate shutdown of the water supply. Divers from the Merritt Chapman and Scott Corporation were sent to inspect the damage, but they found that the pipe was deeply buried under thick mud, making inspection impossible. Dredging was made, and after a few days the damage was finally revealed. A breach nearly 18 inches wide. The conclusion was unavoidable. The damaged section would have to be removed and replaced. But this raised a major problem. How do you cut through thick cast iron underwater? At the time, traditional gas cutting tools that had been invented in Europe some years before were unreliable and ineffective on cast iron. So engineers turned to a new and largely unproven technology, the electric arc cutting torch. What followed was an extraordinary operation. Divers first enlarged the breach so that one of them could enter the pipe. Then, working in total darkness and confined space, they began cutting from the inside, at arm's length. The work was slow, difficult, and physically demanding. Electrodes broke frequently, and positioning was extremely limited. At the same time, additional cuts were made from the outside to fully free the damaged section. After 9 days of continuous effort, the section was finally released and successfully lifted to the surface. A new pipe section was then lowered into place. On one side, it was connected using the original bell and spigot joint. On the other, where the pipe had been cut, a heavy steel sleeve was installed to bridge the gap. Divers carefully positioned the sleeve and sealed the joints using lead packing, secured with bolted rings. Against all odds, the repair was completed. Water supply to Staten Island was restored. At the time, it was described as the most difficult repair ever undertaken by the department. And even today, it remains a remarkable example of engineering ingenuity. A century later, the pipeline is gone, but the ingenuity and the courage behind its repair remain.